Hey folks, Quilly18 here, and welcome to another episode of our Unity tutorial on how to make a drag and drop system using the Unity UI system that was added in 4.6. So when we left things off, we were in a state where we could drag this card around and sort of just have it go wherever it wanted. But our goal here is to make something that looks a little bit like a Magic the Gathering or Hearthstone kind of setup, where we've got a hand and then we've got an area that we can drop the cards into. And we want them to sort of lock into those places. It's not the sort of game where we want things to just be able to be dragged wherever they want. Although, this is potentially completely valid for a different kind of game. That's why there's no one size fits all. So we're going to do a couple of things here. First of all, I'm going to take my card over here. I'm going to make a prefab out of it, and I'm just going to remove it from the board here so that we can arrange a few things. I'm going to make, what else am I going to do? I don't like the fact that the screen is quite this wide, so just to make it look a little bit saner, let me go ahead and just set an aspect ratio here. I like the 16:9. That's your standard computer widescreen. And it just makes, I don't know, makes it a little bit more attractive to me. We're going to make some more adjustments to this relatively soon. So what we're going to do is we're going to set up two areas. We're going to start off, I'm going to right click on the canvas, go to UI. I'm going to add a panel. Again, the only difference between a panel and an image is they have slightly different defaults. The panel is going to be semi-transparent and by default is anchored to all four corners of the canvas. It's not exactly what we're looking for here though. I'm going to take this panel, I'm going to go to the anchor presets, I'm going to hold Alt and Shift, and I'm going to force it to be glued to the bottom of the screen. Then, and again, I'm sorry, I didn't necessarily explain it, I'm going to make sure I'm in 2D mode, right? 2D mode is on. I'm going to make sure I have my rectangular selection tool, not my normal transform tool. It's going to be my rect transform tool. And we're going to bring the top down. Actually, we know our cards are 200 units tall. Let's go ahead and make the hand about 210 units tall. So this is going to be my hand. This is where cards get stored up. We're then going to make a second area. Well, no, you know what? We'll just start with the hand for now. So what does it mean to have a hand of cards? Well, if I go and drag my card prefab back into the scene. Oops, make sure it's on the canvas. There we go. If I put it here, I mean, yeah, all right. So right now it's just sort of hovering around. It's parented to the canvas. If I add the card to the hand, well, that's all good and fine, but there's nothing that stops me from sort of dragging it wherever I want, including when I'm playing the game. I can hit play, and I can still drag it wherever I want, and I mean, that's not really what we want. And what happens when we start to get more than one card in here? Then I've got to, what, like start arranging them by hand? That's not what we want. We would like these to be automatically set up. So what we're going to use on our hand, we're going to use a layout. There are three automatic layout tools. I think there's just the three. There's a horizontal layout, a vertical layout, and also a grid. A grid is maybe the sort of thing you'd want to use in a role-playing game, like something like a Diablo, for example. For us, horizontal layout seems to make a lot of sense. It's going to be a bit weird when I put it in, though. Horizontal, or actually, there, that was a good search. Layout. Grid layout, horizontal layout, vertical layout, and also something called a layout element, which we will be looking at. So if I go ahead and trigger the horizontal layout on the hand, something weird will happen. Boop. Okay, everything's been stretched out. And if I add more cards, we can see pretty clearly what's going on, right? The layout is automatically stretching everything to use the full possible width of the card. And just stretch it out and make it nicely laid out. Well, nice is questionable, but it is definitely laid out. We don't want it to look this way. So what are we going to do? Well, in the hand, in the horizontal layout group script, we have the option of disabling the forced child of expansion in width and height. Now, this looks, all of a sudden it broke. Let's delete these and drag a new card into our hand. It's still broken. So why is that happening? Well, because the card itself, even though, and this kind of annoys me, even though the rect transform here has a width and height, and even though we've turned off the forced child expansion on the horizontal layout group, it still assumes once we put a card in here, you'll notice we can't modify the width and height. It sort of gets stuck. And, you know, we can't necessarily tweak things, which is weird. Maybe it has something to do with anchors. I don't think that's the case. The solution to this is to add something called, let's remove this card. We're going to work simply on the prefab. You can add something called a layout element on here. And what this script does, or this component does, is give a hint to the system of, hey, if I'm in a layout group, I got certain rules that I want followed. For example, I would like to say that my height and width is not flexible at all. So now let's put the card in here. Still doesn't quite work, which strikes me as super odd. But what you can do is specify a preferred width and height. By default, this will set the width and height that your rect transform is. And now let's see what happens when you drop it in there. There. Now it stays the way it is. If I go ahead and duplicate this card a few more times, okay, that looks much better. If I turn off the flexible width and height, but I still have the preferred, then it also works. You're like, okay, so what if I do the force? All right, now, even though I've got a preferred, it will still do the force. What if I leave the force, whoops. What if I leave the force on the hand and go back to the card and specify, not only do I have a preferred height and width, but I'm specifying that I'm not at all flexible. Then it still doesn't do it. I'm like, yeah, it seems a little counterintuitive that, like, you sort of have to set all the things. But now that we've set all the things, we've told the hand, do not force the child expansion. And on the card, we set a preferred width and height and indicated to the system that we are not at all flexible. We can also ignore the layout. But I think that would ignore all aspects of the layout. I might be wrong, though. Let's put the force back on. Let's say ignore layout. Drop the card in there. Yeah, no, it ignores it completely. It doesn't even arrange itself the way we want. So make sure the force expansion is off. Do not ignore the layout. Make sure we have a preferred height and width. Set the flexibility to off. And now if we have cards in here, everything looks the way that it probably should. On the hand itself, I'm going to say the child alignment over here. Instead of being upper left, we're going to say middle center. There we go. That's looking a lot better. Okay, I like that a lot. Anything else we might want to adjust? Well, we could change the spacing between cards. Because we've got a bit of a rounded image on our card, we use that UI sprite. There's a little bit of a spacing technically, but we could also change it in the hand here. We could set a spacing of, say, 4 pixels in between. The padding is not the padding around each child element, but rather around the object itself. We don't really need to adjust that because we've sort of allowed for it with the height. So that's going to be okay. All right, so we've got that. Now, it looks good. If we add more cards, they get added nicely. If we undo them, they get removed nicely. It looks pretty good. If we hit play and we start dragging this Black Lotus around, what do you think might happen? Well, as it turns out, really not much. We can still drag things wherever the hell we want. Why is that? Well, it's because normally, if something is in a grid, you really shouldn't be moving the objects. And the grid doesn't reset the position of anything unless the number of children that are sort of parented to this hand in this case change, right? It's perfectly happy to let you move things around, and that's all there is to it. But if I take one of these cards, let's take this card here. If I remove it by the hand, if I just drag it onto the canvas itself, boom, it does refresh the grid positioning. And if I take this card and put it back on the hand, it goes back where it is. It's worth noting that by default, it gets added to the end of the list. You can see here, card is here. If I reorder it in the inspector to say there, now it's actually the first item on the list in this grid. But the drag this is not really what we're going to want, is it? So what do we want to do? Well, it's actually going to be, the next step is going to be relatively simple. Let's say what happens when we drag, if we're in play mode, if we start dragging, let's remove this card from this hand. Let's remove it from the hand hierarchy. It's pretty easy to do. Go back to our script. We've got this on begin drag event over here. So on drag is where we're actually adjusting our position. But when we start the dragging, what if we do something like this? I like to specify this for my transforms just so that I'm like really conscious of what object I'm modifying. Obviously this doesn't have to be there at all. It's just my personal little thing that I do so I don't get confused later on. When you're doing something like this dot transform equals some other object dot transform, you know, you can do it or not do it. But one of the things we can do on a transform is set a parent. So right now the parent is the hand object, but instead of the hand, we want to parent ourselves to the canvas. We don't just want to set our parent to null. We want to set ourselves to the canvas. Now, we know in this structure that the canvas is basically the parent of our parent. So I guess we can just do this. We're sort of hard coding in things right now, but you know, let's say that that's okay. So we're going to set our parent to our current transform dot parent. Let's do this and see how that works. Then we'll clean it up a little bit. So we're going to hit play. So I'm going to take the leftmost card, which if we watch in the inspector is this card right over here. I'm going to take this, I'm going to start dragging it. Boom. I'm now parented to the canvas instead of the hand, and as soon as I did that, the grid rearranged itself to deal with the fact that it now has a missing thing. And again, if I let go, then it'll, I clicked a second time. If I If I let go, then it'll just stay there. Right now, if I click again, it's going to parent itself to its parent's parent, which means it won't even be part of the canvas anymore, which means it won't draw anymore. Okay, so obviously, this hard coding is no good, but it shows the general idea. Let's go ahead and say this. Okay, normally, in one of these games, if you drag something to sort of an invalid location, let's say I drag it over here, and there's not really any drop spot over here, right? Just empty space, and I let go. Usually, what it will do is bounce itself back into its original position. So let's do that. And actually, before we continue, let's go ahead and colorize these guys. That card's going to be, oh, maybe not that. It's going to be a little reddish. This one here is going to be maybe a little bluish. Ooh, maybe a gray. Dark blue. There we go. Like that. Next card here, we're going to make green. Next card here, it's not attractive, but you know, what can you do? We'll make it sort of maybe a golden color like this. Okay, now we can clearly see each card as things get reordered, right? So again, if I take, let's say I take out the blue one, it'll be quite clear. There we go, the blue one is gone, and the red one and green one have squooshed together. Okay, I like that. I'm gonna just save this scene. So what we're gonna do, we're gonna save our parent. Do something like this. Transform. This is, I don't know, what are we going to call this? Original parent? Or maybe parent to return to? It's a bit wordy. To return to. But it's pretty clear what's going on. We're going to make sure this is set to null by default, just to be clear. It shouldn't be important. Before we change our parent, let's save parent to return to. We're going to save our old parent. And then we're going to reparent ourselves to our parent's parent. I know, a bit wordy, but that's what we're looking to do. When we stop dragging, let's go ahead and set our parent back to where we came from. So parent to return to, we'll do that. So now what will happen is I'm going to pull out the blue card. It's going to be deparented. And as soon as I let it go, it'll be reparented to where it was before and get stuck to the end of the list. Red, green, yellow, there we go. And I'll put out the pink one and then release it. It shows up at the end of the list. There we go. That's, you know, all right. We're digging that. That's feeling a little bit like maybe things should work that way. Let's go ahead and get a second drag zone going on. So we've got our hand. Let's start off by, I'm going to duplicate the hand. Delete the cards that were inside of it. And we're going to call this one the minion drop, or card drop area. Or maybe the tabletop. Hey, I like that. Tabletop, right? You put the cards on the tabletop. I'm going to go ahead and just move it up. It's still going to stay anchored to the bottom of the screen. I'm just going to move it up to be a little bit higher, like so. I tell you what, we'll change the background color to sort of a greenish area there so that we can clearly see it when it's going on. Okay, so now we have this other tabletop. I can, if I want, I can drag cards into it, right? It'll have some cards on there. Cool. And I can drag one of these black lotuses and drop it. It'll go there. Okay, good. And I can still drag these guys, and when I let go, they still return to their parent. But obviously, what we would like right now is to be able to grab one of these cards, drop it here, and have it show up in this list instead of this one over here. So how do we do that? How do we get the card to lock itself to a different parent? How do we get the card to be conscious of where it's dropping? Well, there's two different ways of doing it. One way, well, there's lots of different ways of doing it, but there's sort of two general approaches. Just like we've gone and added these events here, right? These drag handlers on our draggable, we can create a new script. Let's call it something like drop zone, which seems like a relatively good name. And there's more things we can listen to using Unity Engine .event systems. Just like there's an iDrag handler, there is a iDrop handler, which requires you to have a function on here. It's got to be a public void on drop, and it takes pointer event data, same as before. So let's go ahead and I think that's right. Yeah. We're going to go debug.log on drop to, we're going to add our name, undropped Come on, Quill, you can do this. GameObject.name. Okay, well, let's go. On our tabletop, we're going to add the drop zone. And actually, on the hand, we'll add one as well, because we're going to want one on both of those. As before, instead of implementing an interface, instead we could have added an event trigger component here and then wired things up. But again, because I'm worried that I'm going to forget to wire up future event triggers, I really like the idea of just implementing this interface and then it'll just work. This will just get drop. If ever something is being dragged using the built-in Unity UI drag system, if something is being dragged and gets dragged on top of this object and then released, this will trigger. There's a few other things we can do. There's an I pointer enter and exit handler that you can use so that you know when something has come in and out, which is kind of useful. It'll trigger anytime you move the pointer in and out, whether you're dragging or not, but you can test to see if something is being dragged, which is cool. But we'll just leave it for now. Okay, so let's watch the console log over here. I'm going to grab the yellow card over here. You can see we're getting lots of on drag commands. Actually, let's go ahead and get rid of the on drag. It's just a little too noisy. There we go. We'll just comment it out for now. That'll be much, much better. Okay, I'm going to grab this. So we got the on begin drag. Now I'm going to drag it over here and I'm going to release. And we're going to see two things. Or not. We only see one thing. Really? We only get the on end drag? The tabletop has the drop zone script, which should be listening here. Let me verify using my my previous version. I drop handler, public void on drop. This should be sufficient. Why is that not public void data? Oh, hold on. No, I'm doing the wrong one. Let me double check something here. Let me check. Sorry about this. Part of the problem, as always, is that I keep trying to sort of strip it down to its bare minimum. And I guess, just like over here, where we were just doing the drag handler, it's possible that I drop handler is not sufficient. Let me respond to on pointer, enter, and I pointer exit. I'm actually thinking that we may need to listen to both of these. In my test, I had those. On pointer enter, and yeah, we need one of those. Let me duplicate this. Let's see if this is actually going to be required, and then exit. If it is, I will be quite surprised, because it seems like the sort of thing that shouldn't be required. Okay, no, it's definitely not working. That doesn't make much sense to me. What's going on? On public void, on drop, pointer event data is here. We should just spit out the name. It's an iDrop handler, drop zone. Drop zone is here. Drop zone is there. Oh! I know what's going on. Here's another thing. Let's go and add some more debug. I know exactly what's going on. Okay, this is good. I like it when we sort of screw things up a little bit and we can explore something that'll get confusing. Let's add some extra debug messages to the pointer enter and exit. We don't need these, but it'll actually illustrate a point very well. Now, if I mouse around, you can see here, on pointer enter, on pointer exit. Those are triggering over here. Great. And down here, that's lovely. We got lots of that kind of spam. Let's go ahead and clear this log here. We'll still get one more as we come in over here. Let me grab this Black Lotus and now move around. Notice we're no longer getting pointer enter and exit messages. Why is that? We're getting them here, but we're not getting them when we're dragging. Well, the reason is, while we're dragging this card, it's blocking all of the mouse messages. Basically, every frame, the UI system is basically doing a raycast from your mouse position and seeing what it hits. And then uses that to trigger events, like, for example, on pointer, enter, and exit, right? Again, like this. It's doing raycast, and it's like, okay, we're moving here. When I'm dragging the card, the raycast from my mouse pointer is simply hitting the card that I'm dragging. Therefore, it's not able to send the signal to everything else that, hey, the pointer is in you. And when I release the mouse, it sends the onDrag command, but my drop zone never knew that the card or the mouse was on it, so it didn't actually get triggered an onDrop. So what we have to do is when we are dragging a card, we have to stop the card from eating all of the raycasts from the mouse. Luckily, this is very easy to do. There is a component you can add to something called a canvas group. Now, a canvas group allows you to alter things on a card. For example, this is really important when you try to make something become invisible, right? Because if I want to, I could take this card and it's like, okay, color. Oh, I can make it transparent. Great. Let's make the card completely transparent. Oh, it's not doing that because of the way that I have things. Let's grab one of these cards. Right? Let's grab one of the white ones over here. Nice and visible. Let's make this card transparent. We're going to take the color. We're going to drop the alpha down to nothing. Well, all I did is change the transparency of the specific object that I have here, for example. I'm not changing the transparency of everything below it. So what do? Do I have to go and change the transparency of every single one? No, as long as I've got a canvas group. Oh, it's because I'm playing derp, which means that the connection to the prefab is completely broken. All right. Once I got a canvas group on an object, so I've got it here. I've also got it on a prefab. What you can do is change the alpha of the canvas group, and it changes absolutely everything beneath it at the same time. But it's also got these cool options here for blocking a raycast, which by default is on. If you turn it off, now this object will no longer respond to raycast. Now, I can't just turn it off because I think it'll also, it disables the dragging. So that's no good. We don't want that. So we want to have it on normally. But when we start our drag, so here the draggable, when we start doing the drag, we're going to get our component canvas group, and we're going to set block raycast to be false. And then when we stop dragging, we're going to turn it back on. Like this. So now, let's go back to the console log over here. We're going to hit play. We'll get the one message that we've entered. Now when we start dragging, we will still get our pointer enter and exit messages because it's ignoring the card. And now when I drop it here, we should see the on drop in the log. Bam. On drop to tabletop. It's actually very worth noting that the on drop command triggers before the on end drag does, which we can use for different things. So now we've got a few different things. Now the card itself is aware of when the dragging stops. Right? This is the card knowing that it's no longer being dragged. But also, the thing that we're being dropped on top of can get a message to say, hey, something's dropped on you. So there's a couple of different ways we can work this. One, let's say this parent to return to, let's say I make this public. And then in my drop zone, how do we know what dropped onto us? Well, the event data, here, we can even change this. Something like event data dot selected object. I think it's selected object. No, not selected object. Pointer drag. Pointer drag. This is the object being dragged. And I believe it's just a game object. So, was dropped on like that. And let's go ahead and disable these pointer enter and exit messages because they're way too noisy. Let's see this. So drag this one and drop it here. Card 3 was dropped on tabletop. Bam. Exactly what we're looking for to do. We're going to grab this card and drop it down here. Card 1 was dropped on a hand. Wonderful. So now we know event data.portent drag. That's the object that we're dragging around. We can get the component on this thing called draggable. We're just going to assume it exists. Technically, what you might want to do is, one of these, call this if d not equal to null. This is a good idea. And I guess I'll leave this in, but in our little demo, we know there's going to be a draggable on there. So we can say something like d dot parent to return to equals this. So what we're going to say, this dot transform, right, of course. So what we're saying is when you get dropped on here, since the on-drop responds first, it's going to override the parent to return to and set it to the thing that I'm dropping onto, is in this case the tabletop. What happens if I let go here? Bam. Hey, pretty slick. Now we can drag and drop between these two zones. Currently, we have no filtering to say whether that's a legal drop or not. Again, if you're making some sort of role-playing game, you're going to want to do something like, you know, the card itself, the draggable, might want to have something like, you can use, yeah, something like an enum maybe, right? Enum, oops, I hit insert. Something like, weapon, it's basically what slot, this is going to be called slot. There we go. It's going to be weapon, head, chest, legs, feet. And then we say something like public slot type of item. Have it default to be like slot.weapon or something like that. And then with your drop zone, you can do the same sort of thing and say what it is. And then in here, you can make sure that they match one another, right? If D is not equal to null, and assuming I have, should be a draggable.slot type of thing, I'd say what mine is. And then here, if type of item is equal to d.type of item, then, and only then, do we set the parents. All right, so let's do something like that. This is actually, we can test this. Slot does not exist. Draggable.slot.weapon. There we go. So by default, everything is set to weapon. So everything should work exactly the same as it was. There we are. That's okay. But let's change the tabletop to a different type. This is actually your chest slot, for example. Now we're going to hit play, and I will no longer be able to drag things onto the tabletop. See that? I can't. It's not valid. Now, technically, these two white cards are still flagged as weapons, and the hand slot down here is flagged as a weapon slot, so I should be able to drag to down there, but then I can't put anything back because nothing is set to a chest. But if I grab one of these cards, which one is that one? This card is the red one. If I change this to chest, then I should be able to drag this one up to here, but not down here. See that? Very simple way to implement. And one of the things you could do is have a slot called inventory. Inventory. And here you can say by default these drop slots might be of type inventory. So if the item type matches, or I'm an inventory, right? Inventory can accept all kinds of items. So if we're an inventory slot or our type of slots match, then we allow people to drop onto us. And then our tabletop, we'll go ahead and change the tabletop slot to inventory. And now everything should be draggable. There we go. So these weapons I can put in the inventory, and this is a weapon slot, so technically I can do all those. All right, so those are the kind of ideas. Obviously, it doesn't apply to our card game system, but I hope this sort of thing makes sense to you. I'm going to go ahead and delete all this to clear it up, but you can do those sorts of filters. And what you can do in your on pointer enter and exit is you can have things maybe glow if it's a valid slot, or the other thing you can do is on begin drag, you could go and find all the drop zones in the game, right? Because you can do something like GameObject.find objects of type drop zone. This will give you drop zone array, right? Something like this. And then you can loop through all these, and every one of them that is a valid slot for your current item that you're dragging, you make them glow. And then when you end drag, you do the same thing. You go through all the zones and turn all the glow off. That way, everything that's a valid spot for you to drop onto just is highlighted. Yeah, simple little concept that is kind of a cool thing to do. We're going to leave it out of this demo just because I don't think it's going to be required for our purposes, but I hope you find, basically at this point, you can make a full RPG system. And when you end drag and it gets applied to a slot, so again, either here in draggable or in drop zone, you can then apply some logic like, oh, if it's a helmet of +2 strength, then make sure to apply the +2 strength at that point from whatever's appropriate in your system. Now, note right now, we're using these drop zones here to be able to identify what. So the drop zone itself is telling the draggable, hey, you are on me and I am your new parent and we're doing some things, okay? The drop zone is using that logic. It doesn't have to be that way. The other way you could do it is in your, how would we do this? Trying to remember the code. What you can do when you drop here is your event system. Event system .current.raycast all. There we go. Raycast all. It needs a event data, basically because the event data contains the position, the place where you are. Okay. It needs an event data because that contains the position of the mouse. That's basically all that this is required for. And then it wants a list. You can see it wants a generic, a list of raycast results. What this will do is this will do a raycast in a place, wherever the mouse is, right? And except for anything that has the raycast or ignore raycast, what is it called? Blocks raycast. Except for things that have this turned off, right? By default, this is turned on for everyone, so it's okay. It will do a raycast wherever your mouse is, and it will tell you every single object that's underneath there. And so instead of using the drop zone to tell the draggable, hey, you're on top of me, instead the draggable on nDrag can do a raycast and say, hey, what's underneath me? It'll get a list of everything that's underneath it, and then it'll be able to loop through all those and then apply some sort of logic. Depends on what kind of game you're making. For us, this is going to be pretty fine. Although, a good example of this sort of behavior is maybe if one of these was a spell that had to be targeted on something. Why is it still complaining about slots? No, there we go. If this was a spell that had to be targeted on something, that might be a really good example, especially as you're dragging around. You might keep doing raycasts. Or, again, you can have the pointer enter and exit, right? These drop zones with on pointer enter, on pointer exit. I mean, every one of these cards, sure, maybe the card shouldn't be a drop zone. Or maybe it could be, right? If you drag a spell over a card and you let go, instead of adding this card to the tabletop, instead it just targets the thing that you're dragging on top of and fireballs it. Right? You'd have to put in that kind of logic. You know, is the card I'm playing a minion or is it a spell? How do I want to work things? But you know, there you have it. That is that's the gist of it. Now we are going to go ahead and do one more tutorial because there is a very cool behavior in my demo. If let me make sure I've saved this. Let me open the other one, the one I did for practice. In my little demo, I mean, I can click on this deck to draw cards, but that's not relevant. That's, you know, that's not a thing at all. In my demo, when I pull off this black dragon card, you'll see it leaves a space there. And in fact, I can reorder my cards because in ours, every time you play a card, it gets added to sort of the end of the list, right? Like this, it gets added to the end of the list in our current demo so far. But what if you wanted to add it on the left or in the middle? How would you do that? Well, stay tuned for the next episode, folks. Thank you very much for watching. Of course, if you're new to my videos, do be sure to subscribe. I mean, you're watching the second or third video or whatever we are right now, so I hope you've done that at this point. Make sure to drop a like. And of course, if you look down below, you can find a link to download all of the source code for these projects from my website. And I hope you find it useful. See you next time, folks, when we do this. Bye-bye.